Now we have the faults. What is a fault? A fault is a fracture, right? So a break is what we have the fault. When two plates are moving apart, we have a crack, and this crack is known as the fault because of the tangential forces. Because of the tangential forces, and it is also called as a tensional forces, right? So the fault is a fracture which the primary surface are broken and displaced, losing their continuity. So in the fold we have continuity, but in the fault we are not having a continuity. Faults, we are not having a continuity. There is no continuity in the fault. The types of the mountains are anticline, syncline. In the fold mountains, Himalayas, up elevated portion is anticline, and this is syncline in the valleys. We have layers. This is the layer, right? When this layer, compressional forces are acting on this layer. So we have the compressional forces are acting on this layer. It is subjected to anticline and syncline when too much of compressional forces are applied to it. So fault types of the folds. Now we are particularly discussing about the folds. Now particularly we are discussing about the folds, right? So here let us take a normal layer of the surface. When compressional forces are acting, it becomes anticline and syncline. Even further, more compressional forces are acting. If this is 50 and if this is 20, it becomes like this, right? Because this force is greater than this force. So depending upon this, there is a formation of the limbs, and there are types of limbs as well. Now a fold is having two part. When you divide, this is a fold, right? When you divide it, we have symmetrical limb, asymmetrical limbs, right? The fold is classified into types. On the fold, it is having a limb. So this one part is what we call it as a limb. Limb A and limb B. So A and B are symmetrical over here. But when you make the limb over here, limb A dash and B dash are not symmetrical to each other. Now a fold is having two parts of the limbs. This is X and Y is the angle of the limbs. Both the limbs are inclined in the same angle. So when there is a same angle, it is what we call it as the symmetrical. So when they are having same angle, both the limbs are inclined in the same angle, is what we call it as the symmetrical. Both the limbs are inclined. So both the limbs are inclined in the same angle. Both the limbs are inclined in the same angle is what we be having the symmetrical. Both the sides, the compressional force is equal over here. So at both the sides, compression forces. Both the sides, the compression forces are equal. But here, in both X and Y, they are not equal. They are asymmetric force. The angle, they are inclined in different angle. So both X and Y of the angles of the limbs, the angles of the limbs are not equal. So too much of bending along the vertical axis. This is the vertical axis and it is too much of bend along the vertical axis, right? Asymmetrical bend, this is a symmetrical, this is asymmetrical, and this is overfold, it is fold too much, and it is just lying, one limb is lying on the other, this recumbent fold. And when it is totally fall down the surface, it is called hap. The broken, so it is broken thrust folding, broken and thrust folding. So symmetrical, asymmetrical. We'll be having the types as the symmetrical, asymmetrical, overfold. So there is symmetrical. And then we have the asymmetrical. Then we'll be having the overfold. So it is symmetric and then it is asymmetric and we have the overfold. So symmetrical, asymmetrical, overfold, recumbent and happy. Symmetrical, asymmetrical, overfold, asymmetrical, overfold, recumbent. This is overfold, right? In recumbent, this is what recumbent is. One limb is entirely lying on the other limb. So one limb is entirely lying on the other limb is what we'll be having the overfold. And then we have the hap. Happy is the broken thrust folding. Now the different types of the limbs. The sides of the fold are called as the limbs. Sides of a fold. It is called as a limb. So the sides of a fold is what we have it as a limb. So the sides is what we have it as a limb. So the sides of the fold is what we have it as a limb, right? The upfolds are called as anticline and the downfolds are called as a syncline. The sides of the fold is what we call it as a limb. The upfold are called as anticline, which are formed when the strata is bent upwards. The bend is upwards. When the strata, the layer is bent upwards, it is called as the upfold. When it is bent upwards. Then what is called as a downfold is the syncline. Anticline and syncline when the strata is bent downwards. The strata is bent downwards is what we call it as the syncline. Limbs of the fold are inclined at the same angle. It is called a symmetrical fold. So we call it as a symmetrical fold. We have symmetrical, asymmetrical, overfold. Then we have recumbent fold and happy. So symmetrical, asymmetrical, overfold. It is fold too much is when we say it as the overfold, right? So we'll be having the overfold, and after the overfold we'll be having the recumbent fold. So overfold, recumbent, and then we have the hap. Now when the fold, in the fold we'll be having the limbs. The limbs are inclined at the same angle. If the limbs of the fold are inclined at the same angle. So if the limbs are inclined, so we say that the limbs are inclined at a same angle. It is called as a symmetrical fold. If they are inclined at the same angle, it is called as a symmetrical fold. If one of the limbs is inclined more than the other, it is called asymmetrical fold. Asymmetrical fold. If one limb is inclined more than the other, is what we have the asymmetrical fold. Is one limb is inclined more than the other, it is what we call it as the asymmetrical fold. Now what is called as a overfold? If it is a fold where the strata of one limb has been folded beyond the vertical, it is beyond the vertical. Recumbent fold. And if the fold is literally lying down, result of continuous pressure from one of the limbs. So if the fold is lying down, this is because of the continuous pressure from one of the limbs. And what is called as a nappy? The pressure exerted upon the recumbent fold is sufficient to cause it to be torn from its roots and thrust forward to form a nappy. It is, sorry, it's nappy. It's not happy. I have stated it as nappy. Happy. No. I just pronounced it very wrongly. It is nap. I was out of mind that time. The pressure exerted upon the recumbent fold is sufficiently great to cause it to be torn. It is torn from its roots and thrust forward. It is coming forward is what we call it as the thrust forward. So it is coming forward to result is what we call it as a nappy. Right. The Himalayas, and then we have the Alps. Himalayas, and then we have the Alps. So we'll be having the Himalayas, right? The Himalayas and the Alps are example of fold mountains. The Himalayas and then the Alps are example of the fold mountains. Now we have the fault. A layer is there, but due to the radical forces, it is subsiding. So what does it happens? It results like this, a structure like this, right? So this is what we call it as the fault mountains. Example of the fold mountains is Himalayas and Alps. Example of the fault, let's see it. Now, in fold, we'll be having the fold as well as the limbs, right? Whereas in the fault, we are having the horst and graben. The anticline and syncline were present in the fold. Whereas in the fault, we'll be having the horst and graben. Right, tensional forces, because of the tensional forces are acting over here, because we say that the tensional forces are acting over here in the block mountain. So faulting results in the formation of the block mountain are formed by the tension when the fault develops. Horst, we'll be having a elevation mountain given. Horst is the higher portion, and then we have the given. Downward part is called as a horst, which has both the sides graben, and sorry, elevated part is the horst, and a downward part is what we be calling it as the graben. Horst, and then we'll be having the graben, right? Downward part is what we call it as the graben, and upward elevated part is what we call it as the horst. Now normal fault, right? When the tensional forces are acting and we'll be having the on both the sides pulled away, therefore the central portion is elevated, is what we have the normal fault. There are various types of the faults, right? Normal fault, reverse fault, side slip fault, strike slip fault, or transform fault. Now we'll be having the normal fault when on both the sides there is a pull, or when it is acting on opposite directions, the tensional forces. It is a tensional force, but it is a reverse fault, right? Where this is subsiding, whereas one portion is elevating, moving together from each other. Reverse fault. So this is the difference between the normal fault and then we have the reverse fault, and after that we have the strike slip fault. Normal fault, reverse fault, and then we have the strike slip fault. In the strike slip fault, we have they are moving parallel to each other. The blocks are moving parallel to each other. California, San Andreas fault is an example of the strike slip fault. Now horst, and then we have the graben. In a block, the down dropped portion of a fault is what we call it as a graben or rift. So the down dropped portion of a fault is what we of a block is what we call it as the graben. We call it as a graben, or we can also call it as the rift. The upthrust block is called as a horst. So we have the normal fault is when one of the blocks is moving downward relative to the other due to the tensional force pulling the blocks apart is called as a normal fault or a dip slip fault. one of the block is moving downward due to the tensional force. It is moving downward because of the tensional force pulling the block apart. It is called as normal block or dip slip. Right, normal block is also called as a dip slip. Normal fault is also called as the dip slip fault. So we have it as a normal fault, or we can also mention it as a dip slip fault. So we have the normal fault or a dip slip fault. Now what is a reverse fault? When one block moves in relation to the other due to the compressional force, it results in the reverse fault or a thrust fault. So we have a normal fault is also known as dip slip fault. Normal fault is also known as the dip slip fault. Right, we have a normal fault. The normal fault is also known as the dip slip fault. Reverse fault is also known as the thrust fault. The reverse fault is also known as the thrust fault. Strike slip fault, right? Transform fault. No formation of the mountains where both the blocks move across each other, involving no vertical movements. Example, San Andreas fault. There's a gradual difference in the elevation. It is having a continuity. The sudden difference in the elevation. Gradually, it is increasing or decreasing. Sudden, right? Sudden increase or decrease is related to the block, which is more or less steep, highly steep. The steepness is very high and it is a sudden elevation. The sudden difference in the elevation. It is continuous in case of the fold and discontinuous in case of the block. It is folding and faulting. Compressional forces act in the fold. You have compressional forces also in the reverse fault, or we have the thrust fault. Reverse fault is also known as the thrust fault. It is taller, it is very tall. Himalayas, Alps, it is wider. Wideness, it is related to the wideness. An example is the Himalayas, Alps, and example is the Black Forest, which is in Germany. Geomorphic processes are endogenetic, exogenetic. Endogenetic is diastrophic and sudden. Tectonic is building movement. Isostatic is balancing. Eustatic is water movement. Epirogenic and orogenic. Radial upliftment, subsidence. Tangential, compressional and tensional forces. Orogenic, we also have folding is for compressional forces and faulting is also compressional and tensional, which results in the formation of the block mountains. Next, we are going to see with the isostatic movements. What are isostatic movements? Are balancing movements, right? So we are going to deal about this balancing movements. To maintain a balance is what we call isostatic. Similar to the floating mechanism of the ship. When a ship is floating, this amount of water is displaced to another place, right? So that it maintains a balance. Ship displaces equal amount of water to the float. How much of it submerged? The same amount of water is being dispersed over here. So isostatic is related, it's a balancing force. Isostatic movements are related to balance, right? Now we say that the isostatic is related to the balance is similar to the floating mechanism of a ship. So this is similar to the floating mechanisms. It is similar to the floating mechanisms. This is of the ship. So it is similar to the floating mechanisms of the ship. And the ship displaces the equal amount of the water to the float. Then we have the core and a region is present over here. Now we need to tell that all the regions are equal. To maintain the precision of the rotation and revolution, it needs to be stable. The weight experienced by all the sides must be constant, right? When you divide it, the weight experienced at all the sides must be constant for its stability to rotate and revolve. The earth is rotating as well as revolving. So for its rotation and revolution, it needs to maintain a stability. If the stability is being lost, it results into wobbling of the earth, wobbling, shaking of the earth, right? To maintain the precision of the rotation and revolution, it needs to be stable. For stability, the weight experienced by all the sides must be constant. But the outer layer of the crust is not uniform. We do not see a uniform crust. There are some continental crust, oceanic crust, right? Whereas the continental crust are, even though they are 30 to 40 kilometers, and in some areas they are 70 kilometers, their density is 2.7 gram per cubic centimeter, right? So the crust is not constant everywhere. How does this balance is being maintained? In certain areas only we do have the mountains. Even though they are very tall, the density is 2.7 gram, and we have the oceanic crust, which is denser rock materials, 3 gram, which is greater. So pressure difference are there, instability. But the earth is having a balancing mechanism over here. It is what we call it as a eustatic forces. In some parts, the crust will be having the continental. Other parts of the crust, we say that it is oceanic crust. Any continental crust, the boundary where the continental crust is ending and mantle is beginning is deeper. Therefore, continental crust overall weight is equal to the oceanic weight crust. The continental crust must be deeper than the oceanic crust for it to establish a stability. Right? The continental crust must be deeper than the oceanic crust so that they two are balanced with each other. Right? For example, if you take cotton, this is 100 kgs of cotton, the size of 100 kgs of cotton, whereas this is a 100 kg gold. This is the size of the 100 kg of the gold. It is related to the mass, right? So the continental crust must be very big when compared to the oceanic crust in order for it to maintain the stability. Sunlight, precipitation, and the rivers, they are eroding these things, right? Now, due to sunlight, precipitation, and due to the exogenetic forces, you can simply tell it as the exogenetic forces. Due to the exogenetic forces, it causes the erosion of a part of the mountains in the continental and gets deposited in the oceans. Therefore, the balance is being maintained. So, we have the sunlight, precipitation, rivers, erodes a part of the mountain is continental and gets deposited on the oceans. Therefore, the balance is maintained. Right. Now, automatic adjustments, upliftment. Now, it is eroded, right? Now, this part becomes heavy. So, it needs to be elevated. This is what we call it as the isostatic movements. Isostatic is a state of the equilibrium, or there is a balance in the Earth's crust. So it is a state of equilibrium. It needs to maintain the equilibrium, or it is having a balance in the Earth's crust. Now the isostatic movements, they involve vertical movements, right? Under the actions of flotation displacement, flotational displacement between the rock layers of differing densities and mobility to be achieved balanced thrustal columns of uniform mass above a sea level compensation in which topographic elevation is inversely related to the underlying rock density. Mountains have deep roots. The mountains will have deep roots. It has been observed in the Scandinavian Norway coast, glacier mountains were melting because of global warming, right? Melting of the ice sheets has led to gradual rise in the land, which is evident of a series of raised beaches. Now we are going to deal with the eustatic movements. Overall changes in the water level. Water changes is a result of when there is a land is submerging due to rain, the water stays here. When the land is emerging, the water is not present in here. So the water changes is a result of the land emergence and submergence. The water is changing, right? The water changes are due to the land emergence. Land is emerging because the land is emerging, or we call it as the land is submerging. It is because of the land emergence, and then we have the land submergence. The rise or a decrease in the water, overall water quantity increase, and the basin capacity is also increasing or decreasing. Now, water level, melting of the glaciers, overall increase in the sea level, higher, lesser water if there is higher evaporation. This is a basin, right? The water is decreased, the basin capacity or size is being increased. The same level of the water. See, there is a cup and this is 10 gram of water. The same cup, somehow its capacity is being increased. So this is the 10, its capacity is being increased. The same cup's capacity is being increased. Now this is the 10 gram of water. See, the cup's capacity is being increased because of upliftment. Somehow it has uplifted over here, right? This upliftment may be due to the interior forces, endogenetic forces, right? The basin increased its size or the capacity, therefore the water seems to be decreased, right? Some kind of a movement in the oceanic floor, enlargement of the basin, therefore the water decreases. When there is a ridge formation, something is emerging, mountain formation due to volcanoes, the water level looks like like an increased capacity. The overall result is change in the water level is eustatic movement. Eustatic movement involve the worldwide water movement of the sea level resulting from the changes in the total volume of the liquid sea water or the capacity of the ocean basin. Example, the convection in the mantle would arch up an economic oceanic ridge and displace. The convection of the mantle is going to arch up in the oceanic ridge and it causes the displace the water. From the oceanic basin, the capacity of the water increases. These are the topics related to tectonic, isostatic, and eustatic. Previously, we saw that the endogenetic forces which results in the formation, the endogenetic forces which are acting from within the Earth's surface is of two types, diastrophic, and then we have the sudden forces. Sudden forces include the volcanoes and then we have the earthquake. Whereas the diastrophic forces are classified into tectonic, eustatic, and isostatic. Tectonic means it is mountain building. Eustatic is changes in the water level. And eustatic is maintaining a balance. Maintaining a balance is what we call it as a isostatic is maintaining a balance and eustatic is related to the water. Now tectonic is mountain building. Further, it is classified into two types, right? The mountain building is further classified into compressional and tensional forces. Before that, tectonic forces are not mountain building, they are changes in the land. So tectonic is further classified into epirogenic and then we have the orogenic. In orogenic only we have the compressional and tensional forces. Now tectonic movements, tecton in the world means it is building. It is continent and mountain building processes. So what is tectonic movements? Tectonic in the sense it is continent and ocean, mountain building processes. Continent as well as the mountain building processes. So what is tectonic? The tecton is a Greek word. Tecton is builder in the Greek. Tecton means builder in the Greek, and these are continents and mountain building movements affecting the Earth's surface. They include epirogenic and orogenic movements. So they are including two types of the movements. They are epirogenic and orogenic. Epirogenic movements. These are the vertical movements are caused by the radial forces. Epirogenic is vertical, upliftment of the land or subsidence of the land. So either it is subsidence of the land or it is an upliftment of the land. So therefore they are due to the radial forces. They are characterized by this large-scale upliftment, emergence, or submergence of land areas. They are very slow and widespread. These movements lead to the continental building. Example, slow subsidence of the northern coast of Gulf of Mexico and upliftment of the Deccan Plateau. So the Deccan Plateau is facing upliftment and there is a subsidence of the Mexican Gulf of Mexico, northern coast of Gulf of Mexico. So there is a subsidence of the northern coast of Gulf of Mexico, subsidence of the northern coast of Gulf of Mexico. So we say that there is subsidence. What is subsiding? The north coast, only the north coast of the Gulf of Mexico is subsiding. And for upliftment, we have Deccan Plateau for example. Orographic movements. Now, in the orographic movements, these are the mountain building processes by tangential forces. The forces are acting in the tangential direction. Example, let's take the earth. The radial forces are acting in this direction, whereas the tangential forces are acting in this direction. Right. So orographic is because of the tangential forces. We have folding. Compressional forces gives a folding. The folding is by the compressional forces. Thrusting. Faulting is by the tensional forces. So faulting is by the tensional forces. There are two types of the orogenic movements, compressional and tensional. Compressional forces are the forces causing the earth's rocks to push or squeeze against each other, causing the formation of the folds. Now what is a compressional forces? The compressional forces are causing the compression. They push or squeeze against each other. So they are pushing or they are squeezing against each other. So what is the compressional forces? They push or squeeze against each other. These are the compressional forces. Right. Now the forces in the earth's rocks which causes the push or squeezing against each other is what is called as a compressional force. Folds are the structures which are layers of bends. They are distorted or distorted without the loss of continuity. Now, tensional forces. The tensional forces are the ones which pull the rock apart from each other, causing the formation of the faults.